They laughed when the old mechanic said he'd fix their $1 million fighter jet with a wrench and some wire. But when the engine roared to life after every computer diagnostic had failed, the laughter stopped. Because carved into his toolbox was a symbol that only 12 men in aviation history had ever earned. Welcome to Secrets Never Told. Before we begin this incredible story of hidden masters, forgotten skills, and the price of true excellence, tell me in the comments, where are you watching from today? And if you believe stories like this deserve to be heard, hit that subscribe button and help us make sure they never disappear again. Master Chief Thomas McKenzie walked through the hangar doors of Naval Air Station Oceana at exactly 0600 hours, just as he had every morning for the past 8 years. The massive space hummed with activity as young aviation technicians ran diagnostics on FA-18 Super Hornets, their tablets and laptop screens glowing in the early Virginia dawn. At 65, Mac moved with the deliberate pace of a man who'd learned that hurrying rarely solved problems that patients couldn't handle better. He wore the same thing every day: navy blue coveralls that had seen better decades, steel-toed boots that had walked countless flight lines, and a weathered baseball cap with a faded anchor insignia. In his right hand, he carried a metal toolbox that looked older than most of the aircraft in the hangar. The young techs barely glanced at him as he made his way to his workstation in the corner, a small area that the base commander had grudgingly allocated to civilian maintenance support. Lieutenant Jake Morrison, 26 years old and fresh from advanced avionics school, looked up from his diagnostic computer as Mac passed by. "Morning, Pops," he said with the casual disrespect that youth reserves for age. "Got another ancient bird you're gonna work magic on with that museum piece?" He gestured toward Mac's toolbox with a smirk. Mac nodded once, not bothering to correct the lieutenant about his name or his qualifications. He'd stopped doing that years ago. "Today's the day, guys," Morrison announced to his fellow technicians, his voice carrying across the hangar. "Old Mac's finally gonna realize you can't fix modern jets with a socket wrench and good intentions." The cluster of young techs gathered around Morrison's workstation, where multiple monitors displayed cascading error codes from the FA-18 that had been grounded for 3 days. Senior Chief Petty Officer David Chen, the hangar's ranking enlisted man, approached the group with a troubled expression. "What's the status, Morrison?" Chen asked, his voice tight with frustration. "Same as yesterday, Senior Chief," Morrison replied, his confidence faltering slightly. "The engine management system is throwing codes we've never seen before. Primary flight computer won't sync with the weapon systems. We've run every diagnostic in the manual twice." Chen studied the screens, his jaw working silently. The FA-18 was scheduled for a critical training mission in 6 hours, part of a joint operation that had been planned for months. The Navy had already invested 48 hours of technician time and nearly $30,000 in replacement parts, all to no avail. "And the manufacturer's tech support?" Chen asked. "They're stumped too," admitted Petty Officer Second Class Sarah Williams, the youngest member of the team. "Their remote diagnostic team ran a 4-hour session yesterday. They're recommending we ground the aircraft and ship the entire avionics package back to the factory." Chen's expression darkened. Factory repair meant the aircraft would be out of service for at least 6 weeks, missing not only today's mission, but a crucial deployment scheduled for next month. From his corner workstation, Mac had been listening to the conversation while organizing his tools. He'd seen this particular error pattern before, though not on any aircraft these young technicians would recognize. The symptoms reminded him of a problem he'd encountered in 1987, working on a Blue Angels FA-18A that had suffered a similar cascade failure during the show season. He stood up slowly, his joints protesting after decades of crawling through aircraft engine bays, and walked toward the group of frustrated technicians. "Excuse me, Senior Chief," Mac said quietly, his voice barely carrying over the hangar's ambient noise. Chen turned, surprised. In 8 years, Mac had never volunteered input on fleet aircraft. His job was strictly limited to older trainers and aircraft awaiting decommission. "What is it, McKenzie?" "I've seen this problem before," Mac said simply. "Mind if I take a look?" Morrison snorted with laughter. "Pops, this is a Super Hornet, not some crop duster from the Vietnam era. This thing has more computing power than NASA had when they put men on the moon." "I know what it is," Mac replied calmly. "The question is whether you want it flying in 6 hours or sitting in a depot for 6 weeks. Chen studied Mac's weathered face, looking for signs of senility or misplaced confidence. What he saw instead was the quiet certainty of a man who'd been around aircraft longer than anyone else in the hangar. "What do you think the problem is?" Chen asked. Mac approached the aircraft, his eyes taking in details that the computerized diagnostics had missed. He ran his hand along a section of the fuselage near the engine intake, then knelt down to examine the landing gear assembly. "Your problem isn't in the computers," Mac said, standing up and brushing dust off his knees. "It's in the wiring harness behind the main electrical panel. Probably a grounding issue caused by vibration fatigue. The computers are fine. They're just getting bad data from corroded connections." Williams looked skeptical, but the diagnostic systems would detect that kind of problem. "Not necessarily," Mac replied. "If the corrosion is intermittent, the computers might not catch it during static testing, but under operational loads, when the engines are generating vibration and electrical interference, the bad connections start throwing random signals." Morrison's tablet showed no indication of grounding problems. "The electrical system shows green across the board," he said dismissively. "Your tablet's only as good as the sensors feeding it information," Mac countered. "If the sensors are getting bad data, the tablet will show you bad conclusion." Chen found himself in an impossible position. His team of highly trained technicians, equipped with the latest diagnostic equipment, had been unable to solve the problem. Now, a 65-year-old civilian was suggesting the solution involved crawling into the aircraft with basic tools to check connections manually. "What would it take to verify your theory?" Chen asked. Mac opened his ancient toolbox, revealing an array of tools that looked like they belonged in a museum. Analog multimeters, hand-crimped wire connectors, and test equipment that predated digital displays. "Give me 2 hours and access to the electrical bay," Mac said. "If I'm wrong, you haven't lost anything. If I'm right, your aircraft flies today." Morrison couldn't contain his amusement. "Senior Chief, you're not seriously considering letting him work on a $30 million aircraft with those antique tools?" Chen weighed his options. The official repair timeline was measured in weeks. The cost was approaching 6 figures, and his squadron's reputation was on the line. "Do it," Chen decided. "But I want Williams monitoring everything he does." Mac nodded acceptance of the supervision and gathered his tools. As he approached the aircraft, Morrison called out loudly enough for the entire hangar to hear. "Hey everybody, come watch Pops fix a Super Hornet with a wrench and some wire." The comment drew chuckles from around the hangar as technicians paused their work to watch the spectacle. Mac ignored the attention, focusing instead on accessing the electrical bay, a cramped space behind the cockpit that required considerable flexibility to navigate. Williams followed him, tablet in hand, ready to document any damage the old man might cause to the aircraft's systems. "You really think you can fix this?" she asked quietly, away from Morrison's grandstanding. Mac was already removing access panels with practiced efficiency, his movements precise despite his age. "I think I can find out what's actually wrong," he replied. "That's the first step." As Mac disappeared into the aircraft's electrical bay, the hangar's activity continued around them. Other technicians worked on routine maintenance, but many kept glancing toward the Super Hornet, where the old civilian was attempting what their computer systems couldn't accomplish. Inside the cramped space, Mac's hands moved with muscle memory developed over decades. He traced wiring harnesses, checked connection, and tested circuits with an analog multimeter that provided information no digital diagnostic could match. "Found it," he called out after 30 minutes. Williams leaned into the bay. "What is it?" Mac showed her a connector that looked perfectly normal to her untrained eye. "Microscopic corrosion on the main grounding bus," he explained. "The connection is good enough to pass static tests, but under load, it creates electrical noise that confuses the flight computers." "How can you tell?" Williams asked. "It looks fine to me." Mac handed her his multimeter. "Check the resistance reading while I move the connector." As Mac gently manipulated the connection, Williams watched the meter's needle fluctuate wildly. The digital diagnostic systems would have interpreted these fluctuations as normal variations, but the analog meter revealed the true instability of the connection. "The fix is simple," Mac continued, reaching into his toolbox. "Clean the connection, apply dielectric compound, and secure it properly. $10 repair." Williams watched in fascination as Mac performed surgery on the aircraft's electrical system with tools older than she was. His movements were deliberate, economical, and utterly confident. This wasn't the fumbling of an old man trying to relive past glory. This was a master craftsman applying skills that no computer could replicate. 40 minutes later, Mac emerged from the electrical bay and closed the access panels. "Try your diagnostic now," he told Williams. She ran the same tests that had been failing for 3 days. This time, every system showed green. Every error code had disappeared. The aircraft was fully operational. Word spread quickly through the hangar. Morrison arrived with several other technicians, their expressions ranging from disbelief to embarrassment. "That's impossible," Morrison muttered, staring at the diagnostic display. "We checked every connection twice." "You checked every connection your computers told you to check," Mac corrected gently. "Sometimes the problem is in a place the computers don't think to look." Senior Chief Chen approached, studying the diagnostic results with amazement. "How did you know where to look. Mac was packing his tools back into the worn metal box. Experience, he said simply. Seen this exact problem before, on a different aircraft, a long time ago. Where? Chen asked. Mac paused, his hand still on his toolbox. For 8 years, he'd kept his past to himself, content to work in anonymity on forgotten aircraft. But something in Chen's respectful tone made him reconsider. Blue Angels, Mac said quietly. 1987 show season. Same error cascade, same frustrated technicians, same million-dollar aircraft that wouldn't fly. The hangar fell silent. Everyone within earshot stopped what they were doing. Morrison's cocky expression evaporated. You worked for the Blue Angels? Mac didn't answer directly. Instead, he opened his toolbox fully for the first time, revealing the interior of the lid. Mounted there, protected by a sheet of clear plastic, was a patch that made everyone in the hangar take a step back. The Blue Angels wrench insignia, a golden wing wrapped around a silver wrench, with 12 small stars arranged in a perfect circle. Below it, engraved in small but clear letters, were the words Master Chief Thomas McKenzie, Precision Flight Team Support, 1981 to 1995. Chen's voice was barely a whisper. You're one of the 12. Mac nodded once. The 12 were legend in naval aviation circles, the master mechanics who had earned the right to maintain the Blue Angels aircraft during the team's most demanding years. Only 12 men in the squadron's history had ever received the wrench insignia, awarded to those who could maintain 6 FA-18 to demonstration precision for an entire show season without a single mechanical failure. Williams found her voice first. Why didn't you tell us? Mac closed the toolbox, the precious insignia disappearing behind worn metal. Wasn't relevant, he said. You asked me to fix an aircraft. I fixed it. Morrison stepped forward, his earlier arrogance completely gone. Master Chief, I owe you an apology. I had no idea. You had no reason to know, Mac interrupted. And you were doing your job the way you were trained to do it. Nothing wrong with that. Chen approached Mac with newfound respect. Sir, I have to ask, why are you here? Working civilian maintenance on training aircraft? You could be running your own shop, consulting for the manufacturer, teaching at the Naval Academy. Mac looked around the hangar at the young faces staring at him with a mixture of awe and confusion. For the first time in 8 years, he saw genuine curiosity instead of casual dismissal. Because this is where I'm needed, Mac said finally. These aircraft matter. The people who maintain them matter. And sometimes, the old ways are still the best ways. He paused, studying the group of technicians who had gathered around them. Your computers are incredible tools, Mac continued. They can diagnose problems I would have spent days tracking down 30 years ago. But they're not magic. They're only as good as the people using them, and they can only find problems they're programmed to recognize. William nodded thoughtfully. So, when the computers fail, you fall back on fundamentals, Mac finished. You use your eye, your hands, your experience. You remember that aircraft are still machines, and machines still follow the laws of physics, regardless of how many computers are watching them. Over the following days, word of Mac's background spread throughout the air station. Young technicians who had previously ignored the old civilian began approaching him with questions, seeking insight that no manual could provide. Mac found himself reluctantly accepting the role of mentor, teaching skills that the Navy's high-tech training programs had largely abandoned. How to read an aircraft's body language, how to distinguish between normal operational sounds and early warning signs of mechanical stress, how to trust your hands when your instruments disagree with your instincts. Lieutenant Morrison was among his most eager students. The young officer had been humbled by the experience, realizing that his expensive education had taught him to operate systems, but not necessarily to understand them. Master Chief, Morrison said one afternoon as they worked together on a routine maintenance issue. Can I ask you something? Mac looked up from the engine component he was inspecting. Shoot. Why did you leave the Blue Angels? I mean, that had to be the pinnacle of aircraft maintenance. Dream job for any mechanic. Mac was quiet for a long moment, his hands continuing to work automatically while his mind traveled back decades. Because the team changed, Mac said finally. Started relying more on computers, less on people. Don't get me wrong. The computers made things more efficient, more predictable, but they also made the job less human. Morrison frowned. What do you mean? Mac set down his tools and turned to face the young lieutenant. When I started with the Blues, every mechanic knew every aircraft personally. We could tell by the sound of the engine startup whether the plane was having a good day or a bad day. We knew which aircraft pulled slightly left during taxi, which one had a fuel pump that ran a little hot, which one needed an extra half turn on the tail rudder cable. He gestured toward the diagnostic equipment surrounding them. Now the computers tell you everything's within tolerance, and you trust the computers. But tolerances are ranges, not relationships. A good mechanic develops a relationship with their aircraft. They know not just what's broken, but but what's about to break, what's tired, what's running just a little differently than it did last week. Morrison was taking notes on his tablet, trying to capture insights that wouldn't fit in any technical manual. So the computers make us less observant? Morrison asked. The computers make you dependent, Mac corrected. There's a difference. Computers should enhance your abilities, not replace them. When you stop looking, stop listening, stop feeling, because the computer says everything's fine. You stop being a mechanic and become a computer operator. Williams had been listening from nearby, working on her own aircraft. She approached with a question that had been bothering her since the Super Hornet incident. Master Chief, how do we know when to trust our instincts over the diagnostics? Max smiled. The first genuine smile most of them had seen from him. You develop instincts by making mistakes, real mistakes, on real aircraft, with real consequences. The computer will tell you what the manual says should happen. Your instincts will tell you what's actually happening. He picked up a worn wrench from his toolbox, turning it over in his hand. This wrench has fixed more aircraft than some people have ever seen. Not because it's magical, but because I've learned to use it properly. Same principle applies to your computers. They're tools, incredibly sophisticated tools, but still just tools. The magic happens when a skilled person applies those tools to solve real problems. Over the weeks that followed, Mac's influence on the hangar became unmistakable. Diagnostic time decreased as technicians learned to combine computer analysis with hands-on investigation. The number of aircraft returned to service increased as problems were identified earlier and more accurately. One afternoon, as Mac guided Williams through a complex engine inspection, she asked about his time with the Blues. What was it really like, Master Chief, working on the demonstration team? Mac paused, his hands stilling on the turbine blade he was examining. For a moment, his mind drifted back to Pensacola, 1989. 6 Blue Angels FA-18s lined up on the tarmac, their blue and gold paint gleaming in the Florida sun. The memory was so vivid he could almost smell the jet fuel and hear the roar of synchronized engines. Different pressure, Max said finally. When you're maintaining fleet aircraft, a mechanical failure means mission delays, paperwork, maybe some frustrated pilots. When you're maintaining demonstration aircraft, a failure happens in front of 50,000 people and gets broadcast on national television. Williams nodded, trying to imagine that level of scrutiny. But the real pressure, Mac continued, came from knowing that 6 pilots were putting their lives in your hands every single day, not just trusting that the aircraft would fly, but that it would fly precisely enough for formation aerobatics at 400 miles per hour, with 18-inch separation between wingtips. He returned to his inspection, but his voice carried a weight that made everyone in earshot stop what they were doing to listen. I remember one show in Chicago, 1989. Aircraft number 5 started showing intermittent hydraulic pressure fluctuations during practice. Nothing dramatic, just tiny variations that the pilot barely noticed. The computer diagnostics said everything was within normal parameters. Morrison had drifted over, drawn by the story. What did you do? I grounded the aircraft, Max said simply. 12 hours before the biggest air show of the season. The pilot was furious. The commanding officer was furious. The crowd was expecting 6 aircraft, and I was telling them they'd only get 5. But you were right, Williams guessed. Mac's expression grew somber. During the post-show inspection, we found a hydraulic line that was about 6 hours away from catastrophic failure. If that line had burst during the diamond formation pass, he didn't finish the sentence. He didn't need to. The hangar had fallen completely silent. Even the ambient noise of equipment seemed muted as everyone absorbed the implications of Mac's decision. That's the difference between being a mechanic and being responsible for lives, Mac concluded. Your computers are incredible tools, but they can't make judgment calls. They can't weigh the difference between within tolerance and something's not quite right. That's still a human job. Chen approached the group, having overheard the story. How did you know to trust your instincts over the diagnostics? Because I'd learned to listen to the aircraft, Mac replied. Every morning, I'd run my hands along every control surface, every panel, every connection, not looking for specific problems, just getting a feel for how the aircraft was doing. After a while, you develop a sense for when something's different, even if you can't immediately identify what. He demonstrated on the engine they'd been inspecting, his weathered hands moving across surfaces with practiced sensitivity. This engine, for example, it's running perfectly according to your diagnostics, but if you put your hand here, near the fuel manifold, you can feel a slight vibration that wasn't there last week. Probably nothing serious yet, but worth monitoring. Williams placed her hand where Mac indicated and felt the barely perceptible tremor. Her tablet showed no anomalies, but her fingers detected what the sensors couldn't. "How do we develop that kind of sensitivity?" Morrison asked, genuine curiosity replacing his earlier skepticism. "Time," Mac said. "Practice. And willingness to be wrong sometime. You'll make calls that turn out to be unnecessary. You'll ground aircraft that probably would have flown fine, but occasionally you'll catch something that could have killed someone, and that makes all the false alarms worthwhile." Most importantly, a new generation of mechanics was learning skills that bridged the gap between old-school craftsmanship and modern technology. But more than technical skills, they were learning something that no computer could teach: the weight of responsibility that came with maintaining machines that carried human lives. Senior Chief Chen approached Mac one morning with an official-looking folder. "Master Chief, I've got something for you," Chen said, extending the folder. Mac opened it to find a contract offer from the Naval Academy's Aerospace Engineering Department. Teaching position, full professor status, salary that would triple his current income. "They want you to develop a curriculum that combines traditional mechanical skills with modern diagnostic technology," Chen explained. "Train the next generation of naval aviation technicians." Mac studied the offer carefully. It was everything a mechanic could want: recognition, respect, financial security, and the chance to shape the future of his field. "I'm honored," Mac said finally, "but I think I'll stay here." Chen looked surprised. "Sir, this is a once-in-a-lifetime opportunity. You could influence thousands of students, change how the Navy approaches aircraft maintenance." Mac looked around the hangar at the young faces who had learned to respect both his experience and his method. Morrison was teaching a new arrival how to interpret vibration patterns by hand. Williams was showing another technician how to distinguish between normal and abnormal engine sound. "I am influencing the future," Mac said. "Right here. One aircraft at a time, one mechanic at a time. This is where the real work happens." Chen nodded slowly, understanding dawning in his expression. That afternoon, as Mac packed his tools at the end of another shift, Morrison approached with a question that had clearly been weighing on his mind. "Master Chief, what's the most important thing you've learned in all your years working on aircraft?" Mac closed his toolbox, the Blue Angel's insignia, catching the hangar's fluorescent lights one final time before disappearing behind worn metal. "That aircraft don't care about your rank, your education, or your technology," Mac said. "They care about whether you understand them, whether you respect them, whether you're willing to listen to what they're trying to tell you." He shouldered his toolbox and headed toward the hangar doors. "The moment you stop listening," Mac called back, "is the moment you stop being a mechanic and become just another person with expensive tools." As Mac walked out into the Virginia evening, the hangar behind him hummed with activity. Young technicians applied lessons learned from a master craftsman, blending cutting-edge technology with timeless skills. The FA-18 that Mac had repaired was flying its third successful mission of the week. The diagnostic computers showed green across the board, but more importantly, the aircraft sounded right, felt right, flew right, because someone who understood the relationship between man and machine had taken the time to listen to what it was trying to say. Mac McKenzie, one of the legendary 12, had found his place in the modern Navy, not as a relic of a bygone era, but as a bridge between past and future, teaching a new generation that the most sophisticated computer ever built was still no match for the human ability to understand, adapt, and care. In his toolbox, the Blue Angel's wrench insignia waited patiently for tomorrow's challenges, carried by hands that had never forgotten what it meant to be trusted with million-dollar aircraft and the lives of the people who flew them. Sometimes the most important lessons can't be programmed into a computer. Sometimes they can only be passed from one craftsman to another, one aircraft at a time, in the space between what the manual says should work and what actually does work. And sometimes the man everyone calls Pops turns out to be exactly the teacher everyone needed, whether they knew it or not.